Hello everyone, welcome to my chemistry channel BLDASH, short and sweet in chemistry. Now this is the chapter Electrochemistry, that is short revision in electrochemistry. And here the topic is the dependence of EMF on concentration. That means EMF, or you can say cell potential depend on the concentration of electrolyte and temperature, how, and that the relation is called Nernst equation. Nernst equation, that here part 10b, and that is for class 12th. In 10a also, chapter part 10a also, I have explained then how the concentration of electrolyte is related to the EMF. Now the electrode potentials of the electrode and EF standard condition. What mean by standard condition? Standard here, that means the E0, the standard electrode potential. And if cell, then standard electrode potential of the cell. One cell consists of two half cells, and here the concentration should be given and is 1M, that is called standard condition, and temperature is 298 Kelvin. So when the concentration of the half cell electrode and that is 1M, and the concentration of other half cell also same, and temperature 298 Kelvin, then it is called standard condition. From that, Nernst, scientist who observed a relationship between electrode potential and concentration of electrolyte solution. How many half cells are there? Two half cells are there. So in two half cell, that is here calculated, and electrode potential can be calculated, that is called Nernst equation. Nernst equation depend on the concentration. What is the relation? What is the equation? General reaction, suppose here M n plus, that means it is positive, and that means n is the number of electron that is gained or accepted by the M n plus, it gives Ms. Ms means metal solid. Nernst equation is E equal to, listen here carefully, E equal to E0, that is the Nernst equation, that means E electrode potential equal to standard electrode potential minus RT by NF. And here Ln, that is M solid concentration, M n plus, that is aqueous concentration. That means here you can observe that R means what? Gas constant, N is the number of electron, T is the temperature, and F is the, that is Coulomb, the 96500 Coulomb, and here you put all the values. And Ln, what is Ln here? Ln means you can put instead of Ln 2.303 log, 2.303 log. That means here E equal to E0 minus something here it is written that RT by NF Ln Ms concentration by Mn plus concentration. Here if you put that particular electrode, then what you write? E M plus N oblique M, that is this electrode potential, is equal to E0. E0 means standard electrode potential of the same electrode, that is M plus N oblique M, minus put the value RT and F here, general equation you can write here, that is 2.303 RT by NF log Ms concentration, molar concentration, divided by M plus N aqueous molar concentration. So you put the particular value here, you can find here already I told electrode potential, and this is standard electrode potential. That means here if the value is given, okay, you put or you calculate from the equation, and that is for 1M solution of metal ions. Then R is the gas constant, where the value is 8.314 J K inverse mole inverse. And T is the temperature, that is 298 Kelvin. F is the farad of electricity, that is 0.500 coulombs. That means you put all the value, and that very important, and the number of electron gain during the electrode reaction. How many electron gain? So here M plus N or molar concentration sign, that it is molar concentration of ions. So Ms also molar concentration of metal. So you should put the sign molar concentration, that is square bracket, you put that one, and here that is molar concentration of metal. And then if you put all the values here, that means you can say 2.30, 8.314, 298, all the value you will get. Any, you don't know how many number of electron exactly, the general one, so it is N. And so you put all the values here, and now Ms concentration is solid, so you put the value 1, and lastly you can see E equal to E0, standard. E mean electrode potential equal to standard electrode potential minus all the after calculation value comes to 0.0591 by N log 1 by M plus N concentration. That means it is at 25 degrees centigrade, 298 Kelvin. And this is the main equation when simply it is only one electrode. When it is two half cells are there, just like example, Daniel cell consists of two half cell, and here what is the that E cell equal to cathode, and you know E how to calculate E cell, E cell potential, that means you will calculate the cathode potential minus anode. This is the cathode here, and it is the that is anode here. Then mean here you put E cell equal to, what is the value I just told, E equal to E0 minus 0.0591 by N log 1 by M plus N molar concentration. So you put the value, that is cathode and anode, and what is E cell, that is having cathode minus anode. So you put the value of this here. Here you put the value, and then you will get this is this part minus this part. That means this is cathode, this is anode. Cathode, how to calculate from this? From this you will calculate here. From this you will calculate of electrode, whether it is cathode or anode. When cathode, here you put the copper electrode. When anode, you will put this one. So this is the value you will put, and after calculation you will get here. This is the Daniel cell. So copper plus 2, that is cathode, and zinc plus 2 anode. Number of electrons, that is here you will say you will calculate the value, and after calculation you can calculate cell potential. It will confuse only. And so here what happened, so after that calculation you will get the answer E cell equal to E0 cell minus 0.0591 by 2. This is not Z, this is 2. This is 2 mean number of electrons. I hope before that also you have put by 2. So here this is the log, yes, log by 2. 2 you should put here. 2 mean number of electron. So when you will come to this one, then what is the application of Nernst equation? You can find in Nernst equation E cell is there, E0 cell is there. That means simply standard potential is there, simply electrode potential is there, simply you will see number of electron using, and then you will see what is the molar concentration of both cathode and anode ions. Application of Nernst equation, that means equilibrium constant with Nernst equation. How equilibrium constant related with Nernst equation, and here you should know EMF of the cell, use into calculate equilibrium constant. So EMF, that E cell, what you are getting, that is related to equilibrium constant. Then how? At equilibrium, in 11th class also you know, all the electrode potential at two electrode cathode energy become equal. That means here at equilibrium condition, here what is equilibrium, you know also, I will explain now again. All the electrode potential of two electrodes, then cathode anode become equal. So EMF of the cell equal to 0, because here this condition, that electrode potential become equal. Then what happened? Become equal. Let the cell reaction Zn S Cu plus 2 aqua reversible sign. This is now important for the reversible reaction now. Zn plus 2 aqua plus Cus. That means here equilibrium condition comes and here reversible reaction proceeds. When reversible reaction only gives the equilibrium condition. In this reaction, after some time, there is no change in concentration of Cu plus 2, Zn plus 2. That is why you are putting reversible sign, you know, in 11th class. That means here there is no concentration change up to a cation. Here Zn plus 2 and Cu plus 2, here there is no change of concentration. Then what happened here? Automatically the voltmeter gives no zero, that means gives zero reading, no current, it shows no current. That means by two conditions, no change of concentration, no change, not gives any reading in voltmeter, that is zero reading, that indicates equilibrium attained. If equilibrium attained, you know from the 11th class chemical equilibrium chapter, you should know what is equilibrium constant. Equilibrium constant, again you see this reaction here, this reaction when you see, then you can find here, according to equilibrium chapter, this is the product side, this is the product side, and this is the reactant side. That means here Kc equal to, according to the 11th class chapter, Kc equal to product all the concentration divided by reactant all concentration. Now product side which are there? Zn plus 2 and Cus, both concentration you will put here. Then when you put here, then reactant side what are there? Zinc solid copper plus 2. Here this is the molar concentration of copper plus 2 and it is the molar concentration of Zn plus 2. Now what is meaning of Cus concentration? That value become 1 because it is solid. Then if you find equilibrium constant equal to what value? But because Cus equal to 1, Zns concentration equal to 1, then Kc equal to what? Kc equal to Zn plus 2 divided by Cu plus 2, both having molar concentration. Zn plus 2, according to electrochemistry, this part is act as a anode, this part act as cathode. And here, a next equation what you know before, when you put this value in Daniell cell, E cell equal to E0 cell, or you can say E electrode potential of the cell, or you can say cell potential, or EMF of the cell equal to E0 cell, standard electrode potential minus 2.303 RT by 2F. Why 2F? Because here Zn and copper involved. Zinc loses 2 electron, copper plus 2 gain 2 electron. So you put 2 and log. Here molar concentration of Zn plus 2 divided by molar concentration of that is Cu plus 2. At equilibrium, you know E cell is 0 and there is voltmeter reading is 0. Then if equilibrium E cell equal to 0, then what is the value? Because this value is 0. And then this value equal to 0, then E0 cell equal to, the minus sign will be omitted, and here 2.303 RT by 2F log Zn plus 2 aqua Cu plus 2 aqua. or you can say in electrochemistry, here anode what is present, that concentration, and divided by cathode what concentration, divided by that concentration. So Zn plus 2 concentration divided by Cu plus 2 concentration. So I hope it is clear. At equilibrium, what happened? E0 cell value equal to this one. But we know what is the value of Zn plus 2 concentration divided by Cu plus 2 concentration. Then you can know that Kc, here what happened? E0 cell, that means electron potential equal to standard electron potential equal to 2.303 RT by 2F log Kc. What is Kc? Equilibrium constant. What is the temperature? 298 Kelvin. And here for F mean Faraday value, that is 96500 Coulomb, and temperature 298 already told. So if we put all the values except the number of electron and then E0 cell, that means standard electrode potential, a cell potential equal to 0.0591 divided by 2 log Kc. That means it is clear. For general reaction, E0 cell equal to point. See here, instead of 2, you put n. That means here 0.0591 divided by n log Kc. It is the general formula. So log Kc also you can calculate. Log Kc, that means n E0 cell divided by 0.0591. What is the n? N is the number of electron, you should know. And if what is Kc? This anti-log of this value, the anti-log of the value. So you should calculate according to the given value, and you see you put the other values here. And next you come to generally here, general E0 cell equal to 2.30. This is the formula. 2.303 RT by NF log Kc. Then what is an electrochemical cell and Gibbs energy? In electrochemical cell, the relation between electrochemical cell and Gibbs energy. Gibbs energy come to the equilibrium chapter in 11th class, and electrochemical cell that related to 12th class. Then how both are related? In electrochemical cell, what happened? Chemical energy is converted into electrical energy. You know before, from the starting of the electrochemistry, you know here what happened. Chemical energy converted to electrical energy. Cell potential, how it is cell potential related? Cell potential related to Gibbs energy change. Then how? In electrochemical cell, system will work only. In electrochemicals, how it is working? When the electrical energy transfer electrical energy through electric current. What is electric energy? It is in the form of the electric current. Otherwise, you can't you can't calculate what is the number of how the electric current pass and how the system work. System only work in electrochemical cell when electrical energy that is transferring through in the form of electric current. Then here electrical work done. Then that is electrical work. Electrical work is done in 1 second. How to calculate electrical work in 1 second? That is equal to electrical potential multiplied by the total charge passed. How many charge? Charge means here how many coulomb is passed, that is multiplied. That means del Rg, measuring of maximum useful work. So electric work when useful, when electric potential multiplied by total charge. That means here potential of the cell is E cell. The work done when NF is passed. NF is passed here or pushed here, then that work is what? NF is cell. So maximum work mean that is delta G mean NF E cell. What is F? That is Faraday constant, that is 96500 Coulomb. And here E cell mean electrode potential of the cell. Then here NF mean number of electron. Okay. Then After that, you put the value here, the number of electron transfer. So del Rg equal to maximum work Wmx, that is equal to minus NFE cell. Minus NFE cell, that means this is the formula. Maximum work equal to this, that is equal to del Rg. If you know the value G, you can calculate. If the concentration are all unity, concentration means here in Daniell cell, molar concentration of copper plus 2 in cathode and molar concentration of Zn plus 2 in anode. So what happened? This value is unity. Then what happened? This is equal to standard electrode potential. So E cell equal to E0 cell when the concentration is unity. Then what happened here? Then formula will change. Then del Rg0 means standard value. Gives energy standard value, and here del Rg0, that is equal to NFE0 cell, because here when the concentration is unity, E cell becomes to E0 cell, so the formula becomes like this. Let the reaction, Daniell cell again see, Zn losing electron, Cu plus 2 gaining electron, 2 electron only, then N equal to 2. So that is why del Rg, that is equal to minus, because the formula is NFE cell. So here, since it is standard value, so you put this also standard value. That means here you can say this is standard value. This is only electrode potential value. So del G0, del Rg, the 0, that is equal to minus 2Fe0 cell. That means here number of electron only you will put, and E or E0. If E, you check what is electrode cell potential, and if E0, check standard electrode potential. It is maybe given or you should calculate. From this we can calculate equilibrium constant. Now our aim is how to calculate equilibrium constant from Gibbs energy, from standard electrode cell potential or simply electrode potential. Here this is the way we will calculate equilibrium constant. Now del Rg0 means here the Gibbs energy, that is del Rg0 equal to minus RT ln Kc, because this value is equal to NFE0 cell, and that is equal to here RT ln Kc. So del Rg0 equal to minus RT ln Kc. Are you clear? And from E0 cell, del G0, standard Gibbs energy, standard electrode potential, they can be calculated from this equilibrium constant. So from E0 cell, G0 standard Gibbs energy calculated. From that you can calculate Kc. Then relationship between standard EMF and equilibrium constant. Standard EMF means E0 cell. And here equilibrium constant means Kc. How? Both are linked. And in this equation, you are not finding here any E0 cell. But here you can calculate del Rg0 minus RT ln Kc. Kc means equilibrium constant. And here this one, from this you can calculate here del Rg0, that is minus NFE0 cell. When both are related, both are equate, then what happens? So RT ln Kc, this equal to this. RT ln Kc equal to then this value. So what happens here? When both are equal, you put the value, you put the value equally. RT ln Kc equal to NFE0 cell. This is the final one, from where you can calculate equilibrium constant easily. So if you can find here NFE0 cell RT ln Kc, that is equal to 2.303 RT log Kc. So here what happened? You put the value E0 cell equal to 2.303 RT by NF log Kc. Then you put all the value except N. Then what happened? Then here E0 cell equal to 0.0591 by N log Kc. So this is very easy now. Very easy. So from that you can calculate also Kc, that is by the help of anti-logarithm. So you can calculate here. If log K, only Kc required, you calculate. You should know all the values N and E0 cell. If you know, if Kc known, N known, you can calculate E0 cell. That means from a cell representation, you should know which is cathode, which is anode. From the cathode, anode, you know what are the ions, positive ions that is present in the half cell reaction. From the positive ion, you can calculate E0, E cell by the next equation if the concentration is given, and then after that one by one you can proceed up to log Kc. Then here Kc can be calculated by the help of anti-logarithm. So this is the main thing how to, you can observe also here del G standard value, that is equal to minus RTL. Here this minus cancel each other. So when you equate these two, then RT ln K C equal to NFE0 cell. Now here ln is there, so 2.303 will put T, that is 298, and here R gas constant, then N the number of electron. Easy to calculate Kc and also E0 cell. Then from that Kc can be calculated. I hope it is clear to you. And here myself BLDASH, XPGT Chemistry KVS, and I hope you will like and share my channel to others so that 12th class student can be benefited. And my channel is short and sweet in chemistry BLDASH. Thanks for watching my video. Thanks again to all.